Okay, so the answers to all these wretched questions. How are positive ions formed? Well, positive ions are formed by loss of electrons from the outer shell or outer energy level of an atom. Negative ions are formed by gain of electrons to the outer shell of the atom. Why are ions charged? Well, positive ions are charged because there is now in the ion more protons than there are electrons. For negative ions, there are now more electrons than there are protons. Remember, in an atom, the number of protons equals the number of electrons, so they are not charged. Which type of element forms positive ions? Metals and negative ions are formed by non-metals. In terms of the electron arrangement, all ions have filled outer shells. They have an electron arrangement that's the same as a noble gas. Now, drawing your diagrams to show how the following ions are formed. Okay, you should start with sodium atom drawn 2, 8, 1. And then an arrow going to a sodium ion, which is 2, 8. Then in square brackets, and outside those square brackets at the top as a superscript, a positive charge. Magnesium starts 282. It again goes to 28, but because it's lost 2 electrons, the charge outside the square brackets has to be 2 plus. Okay, 2 plus, not plus 2. The aluminium ion, 283, then arrow 2, 8, but now we've lost 3 electrons, so it's 3 plus outside the square brackets. So those are all metals. Those have all formed ions by loss of electrons from their outer shell or outer energy level. We've now got non-metals here. Chlorine is 287 and the chloride ion is 288. It's usual to draw the extra electron that's been gained to the outer shell of the chlorine atom to form the chloride ion differently. So if you've used all crosses for your chlorine electrons, then you might use a dot or a square or something like that for the extra electron that's been gained. Outside the square brackets, there's just minus, not 1 minus, just minus. Okay, the oxide ion. Oxygen is 2,6. It needs to gain 2 electrons to its outer shell to form the oxide ion. And again, you'd put 2,8 in square brackets with a 2 minus outside at the top. If you're not sure where to place these charges, there's a good indication a couple of slides further on. Now, is there a link between the charge on an ion and its position in the periodic table? Well, the answer to that is obviously yes. But there's more to the answer than many of you have put. Some of you have just said, oh yeah, well if it's a metal, it's going to be a positive ion, non-metal, negative ion. But there's more to it. Group 1 all form 1 plus ions, or just plus ions, because they lose 1 electron from their outer shell when they react. Group 2 all form 2 plus. Group 3 form 3 plus. Now group 4 is a little bit odd in that tends to form covalent compounds, sharing of electrons, which we'll talk about quite a bit later, rather than actually forming ions. Now, for the non-metals, to find the charge, you do the group number minus 8. So chlorine is in group 7, and then you subtract 8 from 8 from 7, you get -1. So chloride ion has a negative charge of 1. Oxygen, group 6, and this is true for all group 6 elements, as the previous statement was for all group 7. You do 6 minus 8, so it's -2. If you look at the next group, group 5, 5 minus 8 gives you -3. So the link is more than you have realised, potentially. So this little reaction, yeah, very unfascinating video. Key fact here, reiterated. What happens when sodium and chlorine react together? Word equation, sodium plus chlorine goes to sodium chloride. Symbol equation, 2Na plus Cl2 going to 2NaCl. Now what happens in terms of electrons? Well, you can watch this on the previous video. But the chemical reaction occurs and that outer electron gets transferred across to there. And that is how you should show your ions. You don't need to show the nucleus, you don't need to show that shell there. But look where that positive charge is, Na+, or for the magnesium ion, it'll be 2+ there. Also, some of you have written these structures in your answers. Again, you need to pop a charge on them if you haven't already. And the charge plus, 2+, 3+, minus, 2-. Okay? And look there, I said about drawing the electron differently, and you can see there I've used one type of splodge for sodium's electrons and a different one for chlorine's electrons, and there's the sodium electron transferred across. Now it looked to me like some of you got a bit bored when we had to come on to this bit, and we ignored this fairly important piece of, or these fairly important questions. What happens when magnesium and oxygen react? Well, in this instance, 2 electrons are transferred from the outer shell of the magnesium to form Mg2+, and they go to the outer shell of the oxygen to form the oxide ion O2-. Okay, so you could draw little diagrams like the one for sodium chloride, but just remembering that the charges are 2+ and 2-, if you haven't already put that in your notes. Now I think, and I'm sure you'll correct me if I'm wrong, that only one person of the ones I've marked already has got what occurs when calcium reacts with chlorine. Now there's a bit of a conundrum here. Calcium has 2 electrons in its outer shell. It has to lose both of those. And it doesn't just lose one to the chlorine, it's got to lose the other one to something else as well. We don't just get electrons randomly flying here, there and everywhere. So what actually happens? Well, calcium reacts with 2 chlorines. So calcium loses 1 electron to 1 chlorine to form Cl-, and it then loses another electron to another chlorine to form another chloride ion Cl-. So here we have Ca2+ with 2 times Cl-. So the formula of calcium chloride would actually be written CaCl2. Okay? So that's enough for now. Please, if you didn't understand my answers, then please just ask. Don't worry too much about this stuff on the ionic bond. We will talk about that later. Make sure you've got this nailed, the imbalance of number of protons and electrons, and make sure you've got this little statement nailed here about transfer of electrons. Okay, that's enough for me. I'll post this on YouTube for you, and you can find it on my channel there.